This lecture is involved, it's solving quadratics, and we've already talked about one way to solve a quadratic, which is by factoring. This is part 2. This is an example of the square root method. And so the square root method basically means if I have something simple like 3x squared is equal to 21, so as long as my variable is completely contained, I don't have any other x values. The only thing that I do have is that x squared. I can isolate the squared term, which means I'm going to divide both sides by 3, and I get x squared is equal to 7, and then I can just take the square root of this value of x, because to undo a square root, to undo a square, we take the square root. So I'm going to take the square root of x squared and the square root of 7, and remember that I need to put a plus and minus here. Okay? We put the plus minus there because of the way that the squared term works. For instance, if I had x squared equals 9, both x equals 3 will solve this equation because I have 3 squared is equal to 9. Also, x equals -3 as well will also work because when I plug in the -3, I think of it as in parentheses, and when I square a negative, multiply it by itself, then I end up with a positive number. So when I take the square root of x squared, I remember that both a positive and negative version of that number can solve the equation. So this just leaves me with x equals plus or minus the square root of 7. So we did an example in the previous factoring that was the difference of two squares. I believe it looked like x squared minus 9 is equal to 0. So this is an example of the difference of two squares. It's really, this can also be solved like this. I could just move the 9 to the other side by adding 9, and I get x squared is equal to 9, meaning I can then take the square root of x squared and the square root of 9, remembering the plus and minus, and I get x equals plus and minus the square root of 9 is 3. Okay. Now, this is sort of the easier way to solve this x squared minus 9, but it is important that you recognize it as the difference of two squares as well, which factors as x plus 3 and x minus 3, because in certain situations, that's factoring and simplifying is an important skill to have. So these are just basic ones. These are for quadratics. Basically, it works nice and easy if basically I have ax squared is equal to some c, right? I just divide both sides by a and take the square root and put plus and minus. So any quadratic, when I just have the x squared, and it's always a quadratic if the highest exponent is the squared, it doesn't need to have the constant term, it doesn't need to have the middle x term either. It's a quadratic as long as the highest power is x squared. So just in general, I can divide both sides by a here, and I get x squared is equal to c over a. I take the square root of both sides and put a plus minus here, and it gives me x is equal to plus and minus the square root of c over a. So anytime I just have a plain x squared equal to a number, I can always use this particular method. Now this will also generalize to things that are a little bit more complicated. For instance, if I have x plus 4 quantity squared is equal to 5. As long as I have something squared equal to something else, I can always use the square root method. As long as all my x's are contained inside, or my variables I should say, not just necessarily that it works for x, any variable, as long as my variable is completely contained inside that squared piece, I can use the square root method. So again, I just take the square root of both sides, right? And so I put the plus minus here, right? So then I can take the square root of x plus 4 quantity squared, which leaves me with x plus 4, and then on this side I have plus and minus radical 5. So now all I need to do is isolate my x value. So I'm going to subtract 4 from both sides, which leaves me with x equals, we always write typically the number in front, so I'm going to write -4 plus or minus the square root of 5, and that is my solution. Okay? Let me just do one more example like that. If I have 2x plus 3 quantity squared is equal to 6, then I can also do this. My x is completely contained inside my squared piece. I can take the square root of both sides, putting plus minus on this side, leaving me with, right, the square root of something squared is just that thing underneath. So I just have 2x plus 3 is equal to plus and minus radical 6. Right? I still need to solve for x, so that means I'm going to subtract 3 from both sides first. Right? So I end up with 2x is equal to, I'm going to put the number, the non-radical number in the front, so negative 3 plus or minus radical 6, and then I'm going to divide both sides by 2, and that is my solution. So this is my solution. I actually get two solutions here, right? Negative 3 plus radical 6 divided by 2, and negative 3 minus radical 6 over 2. Right? I also got two solutions over here, too, as well. Negative 4 plus radical 5 and negative 4 minus radical 5. I prefer that you keep your answers in the radical form because whenever you round a radical, that is an irrational number whose decimal keeps going forever and ever. And so when you turn it into a decimal, you're rounding the number instead of leaving it as an exact. So whenever there is a choice, unless it says specifically that you should change your answer to a decimal, you should leave it in terms of the square root. All right, that is the square root method.